This is wanting us to find an equation of a line. And an equation of a line has this format. Y is equal to mx plus c, where m is the gradient and c is the y-intercept. So again, if I was just to plot this thing, c would be the y-intercept, and m is it flat, aka is m 0, or is it positive, or is it negative? All right, the problem is our first equation is not in this format, so we have to make it in this format. So let's start rearranging things. I'm just going to chuck the negative 5x across to the other side. So add 5x to both sides. Okay, now I see that there's that 10 that's stopping us from getting a y on its own. So to do that, I'm going to divide both sides by 10. All right, so then y is equal to, and just to make things easier, right, I can split it up like this, okay, because if there's a fraction, you can do that. It's saying out of 10, basically. So the box is got 10 potential sizes, so you've got something over here that is 6 sizes, and then this other size over here that's 5 times something. So you can split it down the middle. All right, simplifying this, we're going to get divide everything by 2 and divide everything by 5 here. And then just again making it look really nice and putting it into our format here. There we go. All right, done. That is the first step. So what we also have is a little information that says, all right, we know that they both intersect, right? They intersect and they are going to do that at x is equal to 2. And the second line is perpendicular, which means it's at a right angle. So you might see this happen. Okay, and there's a formula for it, right? So we've got this first formula at the top. The second formula that we're going to need is m1 times by m2, so the gradient is equal to minus 1. That there is the one that we want. We said that our m1 is equal to just 1/2. Okay, and so what we're going to need to do then is solve for that. So times both sides by 2, and we get m2 is equal to minus 2. So we've kind of got half of the equation for the second line, but we need to figure out that plus c. So we do know something. We do know that the intersection point between y1 being 1/2 x minus 3 divided by 5. So we do know that that happens at x is equal to 2. So if we plug x is equal to 2 into this guy, we can solve for y, and they intersect, which means that y1 is equal to y2. Okay, so let's just let the marker know what's going on, and we can say sub x is equal to 2 into y1, all right, to find y intersection. Okay, so let's do that. We've got y1 is equal to that 1/2 by 2 minus 3 on 5. Half times by 2, that is equal to just the 1 minus 3 on 5. All right, and we can times this by 5, and that's like saying 5. And we can do the reverse of splitting them, right? Earlier, we said that we could split it along this plus line. We're going to do the reverse of that. So in they come, and it becomes 5 minus 3 on 5. All right, and that becomes 2 on 5. All right, so therefore we have our intersection point at 2 and 2 on 5. So now we sub point into our y2 equation to solve for c. Okay, so we say 2 divided by 5 is equal to minus 2 times by 2 plus c. So really quickly, that's minus 4. And we can solve for c. All right. Now, what's really annoying is that there's that like plus 5 there. So that's like, ugh, super annoying. So what I might do is actually backtrack here just a little bit. And I'm going to say, if we just times both sides by 5, the common denominator, we just eliminate it. That 5 just vanishes. So if we do that now, what we get is just 2, and we get minus 4 times by 5 plus 5c. And so that is a lot easier to manage. There's no fractions, life is good, I'm happy. And then we can just solve for c using our normal rearranging. Okay, and we can say that c is therefore equal to that. So our final equation, a lot of working out I know, our final equation is that we can say that y2 is equal to 2x plus 22 divided by 5. And that is our final equation.